AP Calculus course. Obviously, in this section, we will be studying partial fraction decomposition, but this is mostly like algebra, so you don't need to know like any calculus. Remember, this topic here leads on to integration of partial fractions. So what is a partial fraction? Partial fraction is in this form. A partial fraction is in the form f of x over g of x, right? That's a partial fraction where g of x cannot be equal to 0. Also note, we have proper fractions. We call those proper fractions if the degree of f of x, in other words, the degree on the numerator is greater than, is less than degree of the denominator. In other words, the denominator function is bigger than the numerator function. That's proper. And improper, an improper partial fraction is when the degree is greater than the degree of f of x is basically greater than the degree of g of x. Okay. Let's block it off. Now there are rules for this now. And we're looking at these rules, and that's what we are going to learn in this video. But before we start with the rules, we want to know where did partial fraction come from? Right, so I have 4 examples. What we're going to do is we're going to simplify it and then take the answer and work backwards. You know, like how you have integration and differentiation. If you differentiate the answer of an integral answer, then you will get the inside, or yeah, basically integration is called an antiderivative. All right. Similarly, in this, we have algebraic fractions, which we have done at like grade 9, 10 level. So I have 4 examples here. What we're going to do is we're going to simplify these fractions and then take the simplified answer and come back to the original problem. So the question says, simplify the following and then decompose to check. So simplify these functions first. Get to an answer, take the answer, and come back to the problem. All right, so let's see. Now, what's important to note here is look at these denominator. These are all linear factors, all right? Now, let's simplify this fraction first. To simplify this fraction, we will say the lowest common denominator lowest common denominator from the denominator is x minus 1, x plus 2, x plus 1, right? Because we're trying to get the same denominator, right? So what we're going to write here is basically what you're doing is you're making all the denominators the same. So you'll be left with 2 into x plus 2, x plus 1, minus 3 into x minus 1, x plus 1, plus 5 into x minus 1, x plus 2. Right. And I'm going to write this over each one over x minus 1, x plus 2, x plus 1. Now, can you see that they are equivalent? See, x plus 2, x plus 2, x plus 1, x plus 1, all that cancels out. You're getting 2 over x minus 1. So it's basically equivalent to the first. Okay, Farooq?
Okay.
And then the next one is similar. So you have x plus 2 into x minus 1, x plus 1. So that's the whole idea of lowest common denominator. Or lowest common multiple, right? So now you can clearly see that each one of them has the same equivalence. So instead of doing that in future, we're just going to write the LCD down once. Right, so now what I'm going to do is I'm going to simplify this, right? Let's simplify this is just x minus 1, x plus 1 into x plus 2. Now, if you're simplifying this, you need to open up these brackets. So you're getting 2 into x squared uh, plus x plus 2x plus 2 minus 3 into x squared. This is x plus 1, x minus 1, right? Using polynomial identities, you can just say that is x squared minus 1, difference of two squares, plus 5 into x squared plus 2x minus x minus 2. Right. Now, we still got to simplify this. So remember, this is 3x. 2x plus x is 3x. So 2 times x squared is 2x squared plus 6x. How we got 6x? Because that's 2 times 3x plus 4 minus 3x squared plus 3. Remember over here, 2x minus x is just an x. So that's plus 5x squared plus 5x minus 10. All right, so y minus 10, 5 times negative 2. And that entire thing is over the same LCD, which is x minus 1, x plus 1, x plus 2. All right. And now we can simplify finally. What I wanted to do here is I wanted to open up this LCD. So this is basically x squared, because the question won't be given in that form. It will be given in expanded form. So this expanding the first two will give me x squared minus 1. And we left with x plus 2. So if I expand the LCD, I will get x cubed plus 2x squared minus x minus 2. And what's on the numerator? We have x squared and we have 5x squared. That is 7x squared minus 3x squared is 4x squared. We have 6x. So those were the x squared terms. 7 minus 3, that's 4. Then we are left with the x, 6x plus 5x is 11x. All right. Then you got plus 4 plus 3, that is plus 7 minus 10. That is negative 3. 6, what are we adding? 4 and 3, that is 7 minus 10 is negative 3. We were adding the x's, that's 6x plus 5x is 11x. Yeah, everything looks good. Now, what is a partial fraction? This was just simplifying, all right? This is basic knowledge of simplification. Partial fraction is getting back to the question. Can I take this and go back to the question? So this is creating a question now. So this is rule number 1. So this is your question, because now I want to take this and decompose into these components here. So how do I, so there are decomposition rules, okay? So I want to take this and get back to the question. That's what a partial fraction is, right? So this is your question, right? So how do I go about solving this? So first thing what you need to do is factor the denominator. So this is case one. What we are doing now is case one. Case one is different linear factors. Distinct linear factors in denominator, right? Linear factors in the denominator. Linear factors in the denominator which are distinct, right? Now, let's look at this. How do we know it has linear factors in the denominator without factorizing? Let's factorize and see. So we need to make the denominator equal to 0. So g of x is equal to 0. In other words, first you need to identify that the numerator degree, this is a proper partial fraction. Because remember, next section, you have to go and integrate something like this. So this is a proper fraction. It's an algebraic fraction. It's a proper fraction because the degree in the denominator is bigger than the degree on the numerator, or the numerator degree is smaller than the denominator degree. So we're trying to make the denominator equal to 0. So we're going to say set g of x is equal to, which is g of x, x cubed plus 2x squared minus x minus 2 is equal to 0. We need to factor this out. We can factor this out by grouping, or you can use your calculator to factor this out, right? If you use your calculator to factor something like this out, just 1 second. Let me use my calculator to factor this out. So, when you're putting the values into the calculator, you can go mode 5, and you need to go option number 4, the cubic function. So what's the number next to x cubed? 1. Number next to x squared is 2. Then we have minus 1, and then we have minus 2. Why is it giving us these answers? 1 plus 2 minus 1 minus 2. Did we open up this incorrectly? There's x squared plus that's x cubed plus 2x squared minus 1x minus 2. So what's the issue here? 1, 2, it's minus 1. Minus 1, and then I don't think I selected just ABC value. Oh, sorry, mode 5, option number 4. I think I selected 3, option number 4. So what we have is 1, 2, minus 1, and minus 2. Right, so we're getting x value 1, x2 value which is negative 1, and x3 value which is negative 2. So basically you're factoring this out, you're getting x minus 1, x plus 1, and x, I think it was x plus 2. Yeah, x plus 2. Right, so not really setting it equal to 0. We will set it equal to 0 later, right? So these are my factors from here. Now remember, there are factorization techniques that you can use. If you are not allowed to use a calculator, you're going to group them up, okay? And you also know the rational roots theorem. So grouping this up is taking out x squared into x plus 2, and grouping this up is taking out negative into x plus 2. And then what do you have? You have x squared minus 1 into x plus 2. Right, and then you can factor out x squared minus 1 further. So these are my factors. So now this here, What we have here is basically equivalent to, this implies this part here is now equals to 4x squared plus 11x minus 3 divided by the three factors, which is x minus 1, x plus 1, and x plus 2. Now, how do we decompose this? How do we break it up, break this up into different components like this? How can I come back to the original question? So this is how you decompose. Because these are linear factors, right? We're going to break it up over three different linear factors is x minus 1 plus, always use an addition, x minus 2, x minus 1, x plus 1 over the different, I'm decomposing the different linear factors, plus x plus 2. Right, so I have decomposed them. Now remember, you need to write that this here is identical to. Right, so this here is identical to this. Now, what should I write on the numerator? Remember, when we study polynomial functions, we start with constant, then linear, plus one more than linear, quadratic, one more than quadratic is cubic. Because this is linear, what is the function before linear? What's the smaller function before linear? It is constant. So the constants are a, b, and c. Okay, Farooq, you understand? Now what we are going to do is we are going to simplify this. Right, how do we simplify this? Make an equation. Say 4x squared plus 11x minus 3 is equal to, we're going to drop the denominator. In other words, it's like an equation, right? So you need to solve for ABC. Now there's a trick to solve for ABC. They said this is a into x plus 1, x plus 2. We're trying to get rid of the denominator. So x plus 2, x plus 1, plus b into x plus 1 is there, so the other 2 is not there. So x minus 1, x plus 2, plus c into x minus 1, x plus 1, x plus 1, x minus 1. Now, how do I solve for ABC? You can use to substitute values. So you can say if, look at the denominator, if x equals negative 1, if x equals 1, if x equals 1, then b falls out. Remember, we are substituting into this equation here. Right, so if x is equal to 1, b falls out and c falls out. So if x is equal to 1, why b and c falls out? Because 1 minus 1 is 0. 1 minus 1 is 0. You need to substitute x equals to 1 inside this equation. If x equals 1, so that's 4 plus 11 minus 3. You have 4 plus 11 minus 3, which is equals to, what's, this is a will not fall out, a into 1 plus 2 is 3, and 1 plus 1 is 2. So what we have is 6a is equal to 12, right? 15 minus 3, that's 12. So therefore, a is equal to 2, right? So we have a is equal to 2. Next, how can I go and solve for b and c? How can I solve for b? To solve for b, I need to choose x value as negative 1. See, you need to choose the values in the denominator from here, so it can fall out here. So if x is equal to negative 1, if x is equal to negative 1, then a falls out and c falls out. You're solving for b. So negative 1 will be 4, substituting on the left-hand side, minus 11 minus 3. Not minus 11, it will become, we're substituting negative 1. Yeah, so 11 times negative 1 is negative 11, which is equals to b into negative 2, because minus 1, and then minus 1 plus 2 is 1. All right. So I have now, this is minus 12 plus 4 is minus 8, which is equals to negative 2b. Okay. So b is equal to 4. B is equal to 4. If x is equal to negative 1, 1 second, that's negative 12. Farooq, if you're substituting negative 1 inside here, we're getting 4, negative 11, negative 3. All right, so we're getting negative 8 here. For B, it is negative 2, negative 1 plus 2 is 1. So
Teacher,
negative
teacher,
2b, yeah?
4 minus 11 minus 3 is negative 10. 4 minus 10, 11 minus 3 is
Sorry.
negative 10.
Negative 10, yeah, that's where I'm making a mistake, sorry. Yeah, just bear with me, all right? So that's negative, so that will be 5. Thank you. And next one is, if the value of a, if x is equal to negative 2, if x is equal to negative 2, negative 2 squared is 4, 4 times 4 is 16, 11 times negative 2 is negative 22, negative 3, which is equals to, remember a will fall out and b will fall out because now you're solving for c. If I substitute negative 2 inside here, so it will be c, negative 2 plus 1 is negative 1, and that's negative 3. So I've got 3c. Yeah, I have 3c on this side, and this is minus 25 plus 16. That should give me negative 9. So the value of c is negative 3. Now, if I substitute all this inside here, right, then what we can see is that if I substitute these values inside here, right, what I just solved now, a, b, c, do I come to the answer? What's the value of a? 2. What's the value of b now? 5. And the value of c is negative 3. Okay, so obviously when you're writing negative 3 here, the negative and the positive, you can write it out like this. So negative 3 there. Now, was this the question? 2 over x minus 1. Let's go and check. Let's compare it to what we had. 2 over x minus 1 minus 3 over x plus 2. Yep. And 5 over x plus 1. So there, we have decomposed it. Are we good, guys? Right, Farooq?
Yeah,
We have
great.
decomposed it. So what was the first one? Case 1. Remember, there are 4 cases. Case 1, this is just case 1. Linear factors in the denominator, which is distinct. It is all different. Let's look at case 2 now. Now, not necessarily you will be given cubic always. You can get a quadratic, whatever, right? So next one, question 2. Now, let's simplify this, come to an answer, take the answer and see if you can come back to the question. Right, that's what we are doing. So let's see, for this, the denominator you can see is x minus 1, x minus 1 squared. So the LCD will just be x minus 1 squared. Right? And this is just 2 into x minus 1. And that will remain as negative 3. So if you square this binomial in the denominator, your question will be phrased like this. Okay, since this is a short example, you can just put it next to each other. So this is your case 2. So we have 2 into x minus 2, that's 2x minus 2 minus 3. 2x minus 2 minus 3 is minus 5, and that's 2x. And what's in the denominator? X squared minus 2x plus 1, polynomial identity squaring. Okay, so now your question will be this. So this is your case 2. What is case 2? Repeated linear factors. So what we have, linear factors that are repeated. Why do we say repeated? Because you can see this is x minus 1 squared, and you can have another one, which is x minus 1 cubed. So how do we decompose? What's your decomposition rule? So your question will be this. And you will do like normal, factorizing. So you will factorize this into 2x minus 5, and you will notice that, hey, wait a minute, this is just x minus 1 squared, okay? Or when if you use your quadratic function, mod 5, 3, you'll enter 1, minus 2, and 1. And you'll see that you are only getting one single answer. In other words, it's x minus 1 squared. It has to be a quadratic. So now how do I decompose something like this? Your decomposition rule is x minus 1 plus x minus 1 squared, right? And because this is linear and it's repeated, it's just going to say there's A and there's B. That's it. Now solve for A, B. Now your focus should be here now, because from the factorized portion to this, solve for A, B by making an equation. So we'll solve it in a similar way, what we have done before. So we can say this implies, remember this is identical to, this implies that 2x minus 5 is now equals to A into x minus 1 plus B. Okay? A into x minus 1 plus B. Now solve for A and B. It's easy. If x is equal to 1, if x is equal to 1, you're going to have 2 minus 5, which is negative 3. If x is equal to 1, then A falls out, you're left with B. So B is equal to negative 3. Right. If, now, what other values can you choose? You can't choose any other values besides 1. Now, in this case, you can choose any other value you like. Like, I'll choose x value of 0. So if x value is 0, we have negative 5 is equal to
Negative 1.
If x is 0, 0, yeah, negative A plus B. But guess what? We already solved for B value, but B is already negative 3. So you're allowed to take an answer from before and substitute. So this implies, okay, let's go below this. We got negative 5 is equal to negative A minus 3. Take the negative 3 over, you will get negative 2 is equal to negative A. This implies A is equal to 2. So was that my answer? Was my answer A is 2? 2 over x minus 1. Did we have 2 over x minus 1 and minus 3 over x minus 1 squared? So great. Perfect. Everything is working out. So you saw us took a simple example of algebraic fractions. I created my question, and now I'm working backwards. So there, what was the value of A? The value of A is 2, right? And the value of B is negative 3. Okay? And that's what I started off with, the question. So this is case 2, linear factors that are repeated. Okay, now I just want you to look at something very important before we move on to case 3, because you need to understand the different types of polynomials, okay? Types of polynomials. Right? With these different orders. So a constant, right? Constant is just we start with, okay, you don't have to name the polynomial. We start with the normal polynomial, which is constant is A. Linear polynomial is AX plus B. Quadratic is ax squared plus bx plus c. Cubic is ax cubed plus bx squared plus cx plus d, and so on. Okay. Quartic is ax to the power 4 plus bx cubed plus cx squared plus dx plus e. All right, so those are the different types of polynomials. Now, from these polynomials, I want you to detach the coefficient and tell me what are the coefficients detached. Coefficients. So I'm sure you must have heard of synthetic division. That's where we detach the coefficient. If I try to detach the coefficient for constant, it's just a, right? If I detach the coefficient of linear, is a and b. So a, b. If I detach the coefficient for polynomial of this type, it's going to be a, b, c. Next one is going to be a, b, c, d. Next one will be a, b, c, d, e. Now, simple example. Then let me give you another example with putting down values actually, right? And I want you to detach the coefficient and tell me what those are. So take a similar table. Right? And I'm going to remove all this, right? And put actual examples that are realistic, right? So first one, I'll take one example. I'll say x squared minus 5x plus 3. Then I will take x squared minus 1. Okay? I'll take x to the power 4 plus 2x squared minus 1 and x cubed minus 1. Detach these coefficients for me and tell me what it is. Yeah, Farouk? It's going to be 1.
-5 and 3, yeah.
Yeah. Next one.
It will be 1, 0, 1, -1.
Excellent. Excellent. Next one, because it's quadratic form, must have 3 terms. Yes. Next one. X to the power 4.
4, 0.
No, not 4, not 4. 1.
Oh,
Taking
1,
the
yeah, sorry, yeah.
1,
0,
0,
+2,
two,
-1. 0 again,
0.
-1.
Good. Excellent. Because there's no x term. Right. So just be careful. X cubed minus 1, 1.
0,
Mhm.
again 0,
Good.
and -1.
Excellent. Right. So remember these now. Remember what's the polynomial forms? All right. This is linear. What's the polynomial form before linear? Is a constant. This is quadratic. What's the form before quadratic? Linear. Okay. So when you're doing decomposition, it always takes the form just before this. See, it was linear in the denominator. What did we put on top? Constant. It was linear in the denominator. We put constant. Over here, in this case, it was linear repeated. Now, let's look at the third example. Right, so we want to simplify this first, right? Come to an answer and take the answer and go back and see if it actually works. Okay, so we're going to do an algebraic fraction of this. So this answer is basically equals to, what's the denominator? Denominator is x squared plus 4 into x plus 2, right? Then on the numerator, we got 2x plus 1 into x plus 2. You have to bracket it because you have 2 terms multiplied by 2 terms. Now, minus 3 into x squared plus 4. Right, so that's my, let's try to simplify this. You got 2x squared plus 4x plus x plus 2 minus 3x squared minus 12. And we are going to divide it by the denominator. Okay, I'm not going to take this denominator and expand it because I'm going to end up refactorizing again. It's just an example. In future, when we're doing integrals, then we will factor the denominator and stuff. For now, just keep it like that. Okay, if you want, you can go and expand it. That's x cubed plus 2x squared plus 4x plus 8. Okay, now let's try to simplify the top. To simplify the top, we have 2x squared minus 3x squared, which is negative x squared. And then we have 4x plus x, which is 5x. And then we are left with 2 minus 12, which is negative 10. All over the denominator. Okay, so now we want to take this. That's my new question, right? We want to take this and come back to the original problem, okay? Because this is my algebraic fraction. This is the simplified form. So what is the third case? Case 3 is when you have a quadratic factor in the denominator. Quadratic factors in the denominator. How do we know it's a quadratic factor in the denominator? Because we can't factorize it. And when we try to factorize it, we find that the discriminant is less than 0. We find that the discriminant is less than 0. What is the discriminant? B squared minus 4AC is actually less than 0. That's the reason why you can't factorize it, because you will get complex answers. Now, so how do we know we have quadratic factors in the denominator? Obviously, we need to check the denominator now. We got x cubed plus 2x squared plus 4x plus 8. So let me just group it and try to solve this. If I take out x squared, I'll be left with x plus 2. If I take out HCF from here, 4, I will be left with x plus 2. So now I have x squared plus 4 into x plus 2. You can clearly see that you can't factor this out at all. All right, so this is checking for your denominator. And obviously, you have to factorize every time. When we are solving these, you have to check the factors in the denominator first. Now, how do I go about decomposing this? So I will write it over the different factors that I have. This is actually equivalent to minus x squared plus 5x minus 10 divided by x squared plus 4 into x plus 2. So we're going to say this is equals to x squared plus 4 plus x plus 2. Now what we're going to do here is, see, we have a quadratic factor in the denominator. What's the term before the quadratic? Linear. You see, linear is quadratic factor in the denominator. Before the quadratic is linear. So that's the reason why we put ax plus b. Right? And over here, this is just linear. So don't put a now because you have already used up a. Don't put b. You need to use another constant. What's the term before the linear? The term before the linear is a constant, right? So I can't use a and b because that's already used up. So I use a c. All right. Now, we're going to write an equation, the identical equation, the identity. The identity is equal to, and then we solve for a, b, c, okay? Which is minus x squared plus 5x minus 10. And that's ax plus b into x plus 2 plus c into x squared plus 4. All right. So that's basically dropping the denominator and making it into an equation. Now, if x is equal to negative 2, a and b falls out. You can see that. If x is negative 2, a and b falls out. You can solve it in any order you like. If x is equal to negative 2, a and b falls out. Negative 2, there's going to be negative 2 squared is 4, so negative 4. Yeah, that's negative 4. Negative 10 is equal to, that falls out. And this will become 8c. C into 4 plus 4. So what do we get? Negative 24 is equal to 8c. So c is now equal to negative 6. No, negative 4. The value of c is negative 4. And did we have c value as negative 4
Negative
in the
3, sir.
original?
Negative 3.
Negative 3. Sorry about that. Negative 3. Did we have a value of c which was negative 3? Yes, there's it here. Negative 3 over x plus 2. So you can see you're taking an answer and decomposing and you're coming back to the original sum. That's so great. Now, what are the different values of a and b can we choose? You can choose any other value because you have already exhausted your factors now. You use negative 2, a, b fell out. So choose easier numbers. If x is equal to 0, if x is equal to 0, then a falls out, right? So you got negative 10 is equal to, that is 0. So you're left with b times 2. See, this is 0 and that is 0. So 2 times b is 2b. And plus 4c. Great, because now we have a value of c and now we can solve for b. So negative 10 is equal to 2b. 4 times negative 3 is negative 12. Negative 12 goes over. If negative 12 goes over, it becomes 2, so 2b. So this implies b is now equals to 1, isn't? The value of b is 1. So did we have 1 before here? Yes, we did. There's it here, the 1. And now the value of a we're looking for is 2. Let's see if we can get the value of a to be 2. Let me just do it in the side here. Now, look, you have used 0 and 1. Choose any other value that you like. You can even choose 1. I like to choose easy numbers in the interval from -2 to 2. I wouldn't go more than that. So let me choose a number which is 1. If x is equal to 1, if x is equal to 1, that's negative 1 plus 5 minus 10 is equal to, x is 1, right? So that's going to be 3a plus 3b plus 5c, because 1 squared is 1. 1 plus 4, 5c, yes. That will be, that's negative 5, negative 6. 3 times a, we are solving for a. 3b, b is just 1, so 3. 5 times c, what is 5 times c? 5 times c is negative 15, right? And that is 3a. Let's see if we can solve this. 3 minus 15 is negative 12. If negative 12 goes over to the other side, it becomes positive 12, and 12 minus 6 is 6. So we do get the answer, a is equal to 2, right? So therefore, this implies you got your final answer now. Because remember what you're decomposing this. You got, Farooq? You understanding?
Easy lesson. Yeah. Easy.
All right, so remember the value of a that we just saw for now is 2. So your final answer with the value of a is 2. That was 1 and that was negative 3. There, everything works out. You can see I'm going forward and I'm decomposing, going backwards to show you that it works, all these rules, okay? So in each of these 3 cases that we have done, what did we notice? We noticed that all the algebraic fractions were basically f of x over g of x. It was proper fraction. Now what happens when we get improper fraction? So in this case, what you are getting is this part of here. So what do you do in this case? You can't just go and decompose. Case 4 is something like this. We should have solved the problem first and then we'll done this. All right, case 4. Let's simplify first. Let's do this example and then we can do case 4. Right, so this is the fourth example, and then I will do case 4. Now, what do we do in this case is x plus x over x squared minus 1. So what am I supposed to do here? So let's make it x over 1, all right? So now my LCD will be x into x squared minus 1 plus x divided by x squared minus 1. So what do we have on top? X cubed, that's minus x cubed. Okay, I'm going to change this question, right? So I'm going to make it x plus 1. Let's make it a little bit more challenging. No, because then you can factor that out and that will become much more easier, that problem there. So you make it 2x plus 1, yeah. That will be a little bit more challenging, all right? Let's take out this example here. It's a bad example. All right, so here's a better example. All right, so what we can do now is this here is equal to x into x squared minus 1 plus 2x plus 1, okay? Because there's nothing to multiply here. This is already over x squared minus 1. This is x. Even if you try to cross multiply, you can see what you're getting. Right, so that is over x squared minus 1. Now, the numerator works out to be x cubed. That's minus x plus 2x. That's going to be plus x. You can see this x times x squared is x cubed. X times minus 1 is minus x. But you have minus x plus 2x. It will be plus x plus 1 divided by, if you try to, there's nothing to expand here. So that's just x squared minus 1. Now, what you notice here is that this is an improper fraction, okay? Well, the answer for this is this. Now, how do I go and take this part here? How do I take the answer and go back to the original problem? So this is your case 4. So your case 4 is long division. Okay. What is case 4? Long division. Now, to decompose this, first we're going to use long division and then apply the other 3 cases. Now, how do I apply long division here? Long division here is we're going to decompose. Okay? Decompose this x cubed plus x plus 1. You're going to get 1, 0, 1, 1. Okay? And decompose this, the divisor goes outside. It's going to be 1, 0, 1. Okay, Farouk?
Okay.
Now what do we do? So we divide. 1 can go into 1 time. Now we multiply. 1 times 1 is 1. 1 times 0 is 0. 1 times 1 is 1. And now we subtract. If you subtract those, 0, subtract those, 0. And then we just bring down the 1. Right, so now that's your remainder. Because we can't really do anything here because all 3 of them canceled out. Wait. We made a mistake here. Should be a negative 1 here. Not 1, 0, 1. That's a negative 1. So 1 minus 1 is 2, right? This is a 2 and bring down the 1. Now we can't take 3 terms and divide it into 2 terms. So that's your answer. So what's your answer? Your answer is this. Can you take 3 terms and divide it into 2 terms? You can't. So put a 0 there. Okay? Are we good? You understand why I put a 0 there? We can't take
Yeah,
three. We can
understand. Yeah,
we can't
understand.
take 3 times and divide it to 2 times. Right. So what's your answer here? This is your quotient. This is your remainder. Both these parts are your remainder. Now remember, this is written in terms of detached coefficient. Everything's a polynomial here. So let's see. So this answer is now equal to, what is 1, 0? What's the quotient? The answer is always written in the form quotient plus the remainder over the divisor. So now each of them are function. The quotient is basically x, because 1, 0, there are two terms. Polynomial 2 terms is linear. So it's x plus 0. So it is x. The remainder is 2x plus 1. It's linear. And the divisor is x squared minus 1. Okay?
Great.
So my
But I have
question
one
is,
question.
yes.
Sorry, sir. I have one question. I disturb you. If, for example, it would be like x cubed plus x plus 1 divided by x minus 1. In that case, can we use the short division, or what is it?
Yeah,
There's
yeah.
another type.
Yeah, it's called the synthetic division. If it's
Synthetic
divided by
division, yeah.
x, yeah, you can. Yeah.
Okay.
All right, look here. The way did this problem wasn't too good because I put x squared minus 1. I should have put x minus 1 here rather, but because I put x squared minus 1, remember this here can be further decomposed. I did come to the answer, right? I showed you. This is the answer to this problem. But now, what I want you to do is this completely decomposed? No, it's not. Because remember, x squared minus 1 can be further factorized. So we got, okay, so we have an answer over here. Now let's try to work with 2x plus 1 over x squared minus 1, because that part is proper. Remember, this part is a proper. So this is now equals to 2x plus 1 over x plus 1 into x minus 1. Now we're going back to case 1. Case 1 is distinct factors. So that's just going to be a, and that's going to be b. Right. So that's 2x plus 1 into a into x minus 1 plus b into x plus 1. Now, if x is equal to negative 1, if x is equal to negative 1, you can see what falls out. If x is equal to negative 1, b falls out. That's minus 2 plus 1, which is minus 1, is equal to, if x is equal to negative 1, that's negative 2a. So this implies the value of a is equal to half. If x is equal to 1, if x is equal to 1, a falls out. So that's 3 is equal to 2b. So this implies the value of b is equal to 3 over 2. So what's your final answer for a problem like this? Because remember, you got a and b. So your final answer for a problem like this is equal to, remember that part gave us x plus, what's the value of a? Half. Value of a is half over x plus 1. Plus 3 over 2 over x minus 1. If you want to write it in a better form, it's going to be x plus 1 over 2 into x plus 1 plus 3 over 2 into x minus 1, 3 over 2. Okay, or you can write the 3 over 2 next to the fraction here. Okay, so this is basically your partial fraction. Decomposing this answer over here into is partial fraction. So this, you have to apply long division because the numerator is bigger than the denominator. Right, there are many methods for long division. I just want to do this long division again with variables and confirm that it's actually that. So long division again with variables, note. So I just want to do this long division again with variables, putting the variables, actual variables inside. Even when you're putting the actual variable, you still have to put your 0, x squared and stuff. So this is x cubed plus 0x squared plus x plus 1. And on this side, you can write x squared plus 0x minus 1. Now, x cubed divided by x squared is x, okay? Then x times x squared is x cubed. X times 0x is 0x squared. X times -1 is negative x. Okay? If I subtract both, 0, 0, that's 2. Bring down the 1. Now you stop because this here can't divide this. So remember this is 2x and bring down the 1. So now you're getting the same answer. The quotient is x plus the remainder is 2x plus 1 over its divisor, which is x squared minus 1. And then you can further go and decompose this. So you're getting x plus half over x plus 1 plus 3 over 2 into x minus 1. Right. So now all this is important because all these 4 examples that we have done is very important, and the 4 rules are important because when you're doing integration, that's what you're going to do. You're going to decompose and then integrate these basic simple parts. Now, I do have some decomposition rules that I want you to look at, assuming that have a look at this example here. I just want you to write down the rules for me, not to decompose it, because obviously the main thing over here is the rule. If you don't know the rule, then you can't get the partial fraction. So remember, degree of f of x is less than the degree of g of x. In other words, the denominator is bigger than the numerator. So all these fractions are proper. So just say that if all these things appear in the denominator, how will you decompose? Yes, Farooq, how will you decompose the first one? I'll say a over x plus 1 plus, remember this is only the denominator part. So a over x plus 1 plus
b over x minus 2.
Do the next one.
So this one will be a over 2x plus 1.
Good, good, good.
Then b over 3x minus 2.
Good.
Then plus c over x plus 5.
Because these are all linear. Do the next one.
In this case, it will be like it's quadratic, yeah. In that case,
No, not quadratic. It's a repeated linear factor.
Oh yeah, repeated, yeah. So it
Yeah,
will
so
be
it's going to
2x
be
a over
over
2x plus 1,
good plus
and
b
again
over
b over 2x plus 1
squared.
squared, yeah.
Yeah, do the next one. I mixed it up here. So it's a over x minus 1.
Yeah.
Good. And now focus on this. There's 3 parts there.
So it will be like again b over 2x plus 1.
Good.
And c over
C.
2x plus 1 square, or just
Good. Good.
yeah.
Good. Excellent. And plus d over
2x plus 1 cube.
Yes, that's it. And you stop there. Because remember, if you don't know how to do these from the denominator, then obviously you can't do integration and you can't really go and decompose. If you fail the first part, you have to know which case is coming from. That's why I'm telling you to do this exercise. Do the next one.
It will be a over x.
Excellent.
Plus a over x squared. B over
B.
x squared. B over, yes,
Good.
B over x squared.
And that is the third part is just linear. So C over
Yeah. 2x plus
2x
1.
plus 1. Right. Next one.
A over x.
No, it's just x squared plus 3.
Oh, yeah, right there.
So this is the
Just
quadratic form. Yeah. So
this
what's
one
going to
is
go on
quadratic
top?
form.
Bx
plus b.
Oh yeah, ax plus b. Yeah.
Ax plus b.
Yeah, good. Right. What about the last one?
Okay, this one will be long. A over x minus 2.
You must do one thing at a time. Do this and then move on to the next one. A over x minus 2 plus
B over x minus 2 squared.
good.
Then c over x minus 2 cube.
Right. This
Then
one is done. Now move on to the next one. Plus.
a over no, sorry, d over x square, no, ax plus b, it will be like dx
Okay. One
plus
second.
e.
Yes, excellent. You can't use those letters because you've already used dx plus e. But now this is also repeated. So plus x squared plus 9 squared. And what's going to go on top? The linear. So fx plus g.
G, yeah.
Yeah. That's your answer. Decomposition rules. Right. Right. So I hope you guys understood everything. Don't forget to leave comments if you didn't understand.